Welcome to the Electric Pencil Sharpener DfM, presented by Matthew Allure, Sophia Gerizio, Nick Johnson, Ryan Needle, and Sujay Racha. Our product description is the Electric Pencil Sharpener, which is goal to revitalize a pencil's writing point by shaving away worn wood and graphite to create a sharp pencil tip. This pencil sharpener is also automatic and is powered by batteries. The actual sharpening is done by a sheet metal blade assembly. The body of the sharpener is made by injection molded plastic and is constructed primarily via manual assembly. Here's the exploded view of the electric pencil sharpener. Customers, our primary customer is school districts and office buildings, primarily used by students and employees. Our secondary customers are private consumers for use within a home, such as a home office. Here's our FAST diagram. Our primary functions are retain waste, prevent injury, remove wood and graphite, assure dependability, assure convenience, enhance product, and please senses.
Shown are two fishbone diagrams, each with a different assembly sequence. Both sequences begin with the motor and battery housing and end with the sharpener container. Sequence 1 assembles the lower portion of the sharpener first, which includes the gear, motor, metal inserts, motor cover, battery cover, the lower sharpener body, and then assembles the top of the pencil sharpener with the blade casing, spring, and retaining cap, main sharpener body, and the sharpener container and feet. The second sequence is just the top assembled first and then the bottom, and each assembly has 5 sub-assemblies, the metal inserts and motor cover, the feet, battery cover, and sharpener lower body, the blade and blade casing, the spring and retaining cap, and the sharpener container and feet. The assembly sequence comparison was generated by giving each assembly a value ranging from 1 to 3, with 3 being the best. This shows that the first sequence, which was assembled from the bottom to the top, was preferable as it allowed for better location of features, fastening, and handling. The function component mapping matrix was generated to ensure that each part of the assembly served a purpose. The criteria of the FAST diagram were used to validate this. We determined that the sharpener container serves to retain waste, the main body and blade casing help to prevent injury, the blade removes material, the main body, retaining cap, spring, and blade casing are used to orient the pencil, the feet on the bottom maintain the sharpener's position on the table while it's in use, the sharpener container facilitates cleaning, the motor, gear, and metal inserts allow the sharpener to operate automatically, and finally the main body, battery, motor housing, and motor cover, lower body, battery cover, and sharpener and container work to reduce noise.
Here we have compiled a bill of materials which lays out all of our unique parts and describes both the manufacturing process as well as the assembly process used with each individual part. Some of our parts are purchased, some are injection molded, and others, more specific parts such as the blade, include processes such as stamping, heat treating, and grinding. This bill of materials also lists the material of each part as well as all of the costs that go into manufacturing and producing these parts. The total cost of the parts comes out to $12.69, which is within the 50 to 70% range expected from the retail price of the electric pencil sharpener. The quad chart for DfM and A is depicted below. The functional importance was analyzed using the mapping matrix, where we were able to determine the relative importance of each of our unique parts. And then using the bill of materials, we were able to analyze the relative manufacturing costs of each parts. This led us to the conclusion that the sharpener main body had limited functional importance with a high cost, which is an area that we are able to improve on the electric pencil sharpener design, where other parts such as the blade, motor, and battery housing also had high functional importance and high costs, meaning that that's not something we can necessarily improve.
Here's a functional differentiation table, dividing the different functives of the product based on what is the same for both customer groups and what is different. The only functives that differ between the customer groups are preventing injury and minimizing noise, which target the primary customer group, in this case, schools and office buildings. Next is the component commonality table, showing which platforms remain constant between variants and the main sharpener body, which is modular. This is due to the fact that based on the function component map matrix from earlier, The main sharpener body both prevents injury and minimizes noise, which were the key differences identified with the functional differentiation table.
Thank you, Matt. Here's our module component, the sharpener main body, for the secondary customer group. At-home users will most likely be placing their sharpener on a desk or a work surface. Integrating utensil storage into the sharpener increases its footprint efficiency. Additionally, offering the sharpener in multiple colors will help it blend into a user's home space and match the existing design language. When comparing the secondary module to the primary, the only difference is the sharpener main body. The secondary module will require different tooling to include the molded utensil cups on both sides. Since the interface of the modules are not changing between them, there is no difference when compared to the original design. Both modules use a snap-fit to fasten to the body of the sharpener container and the sharpener lower body. The first assembly sequence is the selected sequence from slide 8. The main sharpener body is the only module component for the pencil sharpener, which causes the assembly diagram to branch into two paths. Using delayed differentiation, the main sharpener body can be assembled as the second to last step to reduce the number of stages that require two paths by one stage. Thank you.